Okay, here's some integration by part examples I said that I would get up. Remember, integration by parts, we're going to use this form that any integral of the form integral of u dv can be written as uv minus integral v du. So what we're going to have to do is identify primarily what u is going to be. And remember, in lecture we said let u be the function that can break down when you differentiate, meaning break down in powers as you differentiate. So in this example, we're going to let u be simply x. dv, by the way, is going to be the rest of the information you see here, meaning that dv is now going to be the e to the x dx. It's the rest of the information in our integral. So that this portion is my dv, this portion is my u, and so on the right here I have my u, and I have my dv. So as you can see, on the right side here, I need the rest of this information. I need u times v, and then I need minus this integral of v du. In other words, I have to determine, since I know what u is, I need du. So du dx is 1. I can solve for du, and I get du being 1 times dx, or simply, we should say that du is going to be our dx. Now, in purple here, we have dv equals ex dx. What that means is that v is going to be the integral of ex dx. So I just have to integrate with respect to x now, and that's going to be ex. So this is my v. We're going to use all of this information. We're going to use the fact that v over here, we're going to use our v being simply ex. We're going to use our u being x over on this other side here. We're going to use this u as x. And together we got now uv. Now, du is also going to be used here. So let's put this all together. I have uv, where u is x and v is ex. So this integral is going to become equal to x ex minus the integral of v, which is ex, and then du is going to be dx. Again, I'm using what you see over here. Here's my u. And here's my du. V is ex, v is ex. This is of the form uv minus integral v du. Now, we're going to be going through, examples with problems like this. We're not done. However, we just now have to integrate what we see here. This is x ex minus e to the x plus rc. This is an example that we're doing in integration by parts. These are the extra examples I'm going to put up for us. Second example, we can have the integral now of x sine x dx. Okay, again, we'll let u be x, and we're going to let this whole thing be our dv, so that we say u here is x, which means du gives us our dx, dv is sine x dx. So my dv will be, again, this whole thing, where my u is just what we see here. It's going to be the first function. Here's our u. We'll use integration by parts, and integration by parts is going to be the integral of, or we should say, this integral here. Let's write it all over. The integral of u dv is uv minus integral v du. So you want to get used to actually writing it this way. So as you can see, we need uv. We need the integral of v du. In other words, we need the v function and du. We already have du. Du is right here. So in order to get the v function, since dv is sine x dx, this means that v is going to be the integral of sine x dx. Now the integral of sine, now let's think. The derivative of cosine is minus sine. So the integral of sine is minus cosine. So we have our v function. V is minus cosine. Let's put this all together. uv is x times a minus cosine x minus the integral of v is minus cosine x, and du is dx. So we get minus x cosine x plus the integral of cosine x dx. We just now need to integrate cosine. And we know the integral of cosine, this integral here, is going to be sine. So we'll end up with minus x cosine x plus sine x plus my c. Okay. Let's try some more examples here. You're going to have now x may be e to the minus x dx here. Again, we're going to use integration by parts. We're going to identify our u here. U is the function that will break down very easily when we differentiate, at least by powers. That's what we typically want to have. And then we want the rest of this to be dv, meaning, let's write this format. You have the integral of u dv being uv minus integral v du. Okay, so let's see. Since u is x, I get du equals dx. Let's find v. dv is e to the minus x dx, which means v will be the integral of minus x dx. Now, let's be careful here. We're going to need to use here u substitution. However, the variable u is already taken. We can't use u here. So let's call this t sub. And what I'm saying is you're going to let now t be minus x, and so dt becomes negative dx. If I solve for dx, I get minus dt. So my t substitution works like this. The value of t here is negative x. We're going to replace this here for negative x. We know that dx here is minus dt. So this integral here is going to become, at least our v becomes, the integral of e to the t now, not minus x, and dx is replaced with minus dt, which gives us negative integral et dt. So that v will become minus e to the t, because I can integrate now e to the t. The negative sign here is a constant. So you get minus e to the t. Don't forget, t is really negative x, so this would be minus e to the minus x. This is my v. V is minus e to the minus x power, and u is x, du is dx. We're going to use this in our integration by parts format. uv minus integral v du. So here's what we get. X minus e to the minus x minus integral v is minus e to the minus x, du is dx. X e to the minus x plus the integral of e to the minus x dx. I need to know what this integral is. Okay. Now the integral of e to the minus x dx we already actually obtained. It's our v. It's right over here. So I can replace this integral with minus e to the minus x plus my c, so that the final answer I'll have here will be minus x e to the negative x power minus e to the minus x plus c. Here's my answer. Four. These are getting progressively more difficult. Let's look at this example here where I have x now sine of maybe alpha x dx, where alpha is a constant. Now, again, we'll let our u be x since it breaks down very easily. My dv will be the rest. So u is x, dv is sine x, or sine alpha x dx. Okay, so u is x, du becomes dx. My dv is sine alpha x dx, which means v will be the antiderivative of sine alpha x dx. Now, we're going to have to use again a form of substitution. Typically, it'll be u substitution, where I'm going to let now t would be alpha x. Typically, it's u sub. U sub because we have a composition of functions. I'm going to call this alpha x t. This is what we see here. So then, differentiate t with respect to x, I get dt dx is alpha, or dt becomes alpha dx. This is what we're going to use here in our t substitution. So let's go back here. What do we know? That v is the integral of sine of t. Dx is replaced with, we made a mistake. We're going to solve for dx. So let's go back here in red. Dx will be dt over alpha, because I have to replace this dx here with what it's equal to, and it's the dt over alpha. So I get now dt over alpha. This is a constant, and I can pull it out. So I'll have 1 over alpha, the integral of sine t dt. Now, the derivative of cosine is a minus sine, so the integral of sine will be minus cosine. So I get 1 over alpha cosine of t, which is really minus 1 over alpha cosine. T is alpha x. Now, this is my v. So we're going to use this v. We're going to use our u and our du. Okay, we're going to use these because in integration by parts, any integral of the form u dv is uv minus integral v du. This is our integration by parts format. So let's scroll down here. We got u being x, and we got minus alpha cosine alpha x. So I have x minus 1 over alpha cosine alpha x minus the integral of v, which is minus 1 over alpha cosine alpha x. And let's see, du again is dx. There we go. So it's dx. Let's simplify. Minus 1 over alpha x cosine alpha x plus 1 over alpha integral cosine of alpha x dx. Once again here, we have, let's maybe focus on this here, a t substitution problem to do. Okay, we got t sub. You would call it u sub. That's what it's known as, where you let actually t here be alpha x. And so then dt is actually going to be alpha dx. Or we can say your dx will be dt over alpha. So this portion here is my t, and then dx will be dt over alpha. Dx is dt over alpha. We'll replace this dx with dt over alpha. Replace alpha x with t. We're going to get the following integral. We get 1 over alpha integral cosine of t dt over alpha, which gives us 1 over alpha squared cosine t dt. This is what we're going to integrate. Now the derivative of sine is cosine, so that this integral is really sine of t. In other words, we get 1 over alpha squared sine t. And ultimately, we're going to have a constant we're going to add there. So this will be plus c. This is what I get when I integrate cosine alpha x dx. Now let's not forget, replace then t with alpha x. Okay, we'll add our c at the end. And this is what we just replaced. So it's a function of x now. So altogether, I have minus 1 over alpha x cosine alpha x. Let's get prepared to give our final answer. Minus 1 over alpha x cosine alpha x plus 1 over alpha well, it's 1 over alpha squared sine alpha x. 1 over alpha squared sine alpha x. 1 over alpha squared sine alpha x plus your c. Integration by parts. Let's see, that was number 4. Let's do number 5. Let's double check something here. Okay. Number 5. We're going to try to integrate a more complicated question. X squared cosine beta x dx. Again, u will be x squared which means du dx is 2x, or du will be 2x dx. dv is cosine beta x dx, so that v will be the antiderivative of cosine beta x dx. Let's try that. Just be consistent, I guess. dv cosine beta x dx, v will be the antiderivative of cosine beta x dx. Now, again, we'll have to use t sub. And when you do, you'll find that v will become 1 over beta sine beta x. You'll find that by using t sub as we did earlier. Derivative of sine is cosine. Okay. So, now let's use our format. Remember, the integral of u dv is uv minus integral v du. We know what u is. U is x squared. Du is 2x. V is what you see here. So, here we go. This integral will equal uv. So it's 1 over beta x squared sine beta x minus the integral of v, which is 1 over beta sine beta x, times du, which is 2x dx. So let's simplify. 1 over beta x squared sine beta x minus, let's see, 2 over beta integral x sine beta x dx. So we're going to need to know this integral here. Did we integrate something like this? Integral of x sine beta x? Let's check. Integral of x sine alpha x, number 4. Well, alpha and beta, those are constants. So we get as a final answer what you see here. Only we're going to use the constant beta. So let's use this. 1 over beta x cosine beta x. This integral could be replaced with 1 over beta x cosine beta x. And it's minus, so let's not forget that. Plus 1 over beta squared sine beta x. And we'll have our constant at the end here plus our c. So we get to actually replace here, if you take a look at this. Let's put it in red. Let's highlight this. This integral is what you get here. Let's put this answer all together. So we got 1 over beta x squared sine beta x. Okay. And then I got this multiple of minus 2 beta. So I have a minus 2 beta. Let's see what this is multiplied to. Minus 1 over beta x cosine beta x. Minus 1 over beta x cosine beta x. Plus 1 over b squared sine beta x. Plus 1 over beta squared, sine beta x. Let's double check if we're right. It looks like we're okay. Okay. Let's simplify this here. We get 1 over beta. Let's put it a little lower. I get 1 over beta x squared sine beta x plus 2 beta squared x cosine beta x minus 2 beta cube looks like sine beta x. Don't forget to add your c. This is the integral. That was number 5. Let's look at this number 6 here. We're going to look at this integral here, e to the minus x cosine x dx. This is very similar to a question we did in class. Let's recall maybe what we did in class. Well, let's try this one here. Okay. Let's try this. Again, I believe we're going to use this in the future. So it'll be helpful for us to do this one again. Again, we let this be u. We let u be e to the x, so that du dx is e to the x, and du will be e to the x dx. Let me remark that, again, u is the function that you want to break down in terms of powers of x, like, x squared becomes x when you differentiate it. X cubed becomes 3x squared when you differentiate it. So you reduce the power. When you differentiate e to the x, it does not reduce. If I differentiated sine, on the other hand, right, because I could have let sine be u, I'll get cosine, so it certainly doesn't, break down in powers as well. So we're going to go with our format of integration by parts. We've seen this in class already, but I'm going to use this in a later example. So let's try this again. We're going to have to integrate cosine, and the derivative of sine is cosine, so this is going to be sine. Okay, let's be careful. Derivative of sine is cosine. All right. This is my u. Here's my du. Again, my v is sine. So integration by parts. Let's write this down. Integral of u dv is uv minus integral v du. So that will get e to the x sine x minus the integral of v, which is sine x, times our du. Now du here is e to the x dx. In other words, this integral is e to the x sine x minus the integral of e something happened here. Oh, we made a mistake. Let's go back. We found it. Here we go. Oh, we made a major mistake. I'm glad we caught it. This would be antiderivative of sine. We get minus sine. Ooh, minus cosine. So we're taking the antiderivative of sine. Derivative of cosine is minus sine. So this antiderivative is minus cosine. Okay, that makes sense. So this is my v. Let's go back. Let's erase this. Okay. I'm going to call this integral I, by the way. So let's try this out. This integral I becomes uv, so it's going to be negative e to the x cosine x. Okay, negative e to the x cosine x minus the integral of minus cosine x times du, which is e to the x dx. So this I integral is minus e to the x cosine plus the integral e to the x cosine dx. Okay. So like the example in class, we're going to apply integration by parts again. So I'm going to say here, use IBP again, integration by parts, where my u is e to the x, okay, which gives you du being ex dx. And this time my dv is going to be cosine x dx. Let's be careful. The antiderivative of cosine dx. Now the derivative of sine is cosine, so the antiderivative here is sine. Let's make sure we have what we have. V is sine, or have what we need. U is e to the x. Oops. And du is ex dx. So for this particular integral we're looking at here, right? Let's put it in red. Trying to integrate this. Now by integration by parts, we know this portion becomes, let's put it in blue just in case. This portion will be uv. It's a different uv, or it's a different v, that's for sure. So over here, let's just say what we get. It's e to the x sine x, okay, minus integral of v sine x du, which is e to the x dx. So let's kind of put all this together here. And on the next page, so we have here I being minus e to the x cosine x. So we're going to have I being minus e to the x cosine x. Plus, okay, plus e to the x sine x plus e to the x sine x. All right. Minus the integral of e to the x sine x minus the integral e to the x sine x dx. And we called this earlier here I. This is the same I. In other words, this integral and this integral are the same. So how you approach it is you can say, all right, let me add that integral I to both sides. And what you obtain is, now 2I will be, let's start our terms with positive. Let's put the e to the x sine x first, minus e to the x cosine x. Let's kind of do that here. And, we can factor out if we wanted the e to the x, and so we get a sine x minus cosine x if we like. Now you can divide both sides by 2 algebraically. Okay, so you get your 2's to cancel. You end up with I being 1/2 e to the x multiplied to the difference of sine and cosine. Don't forget to add your c. You're done. Now, I don't know what number this is. Let's check. Number 7. They give you a variation. So number 7, we're going to have this integral of e to the minus x cosine x dx. It's a similar process. We just have to be careful with the e to the minus x, meaning you're going to let u be, again, this e to the minus x. And when you do that, du dx is, I'll write down every detail. The point I'm making is you're going to have to use chain rule. because what you see is a function as a power up there. So I'm looking at this here, this power. There's a function. By chain rule, we have to differentiate that function. Derivative of minus x is -1. So you're looking at this relationship that du will be simply negative e to the minus x dx. We're going to use this. Okay, we're going to use this for du and this for u in integration by parts. Purple, let's work on the dv here. So dv now, this whole thing will be dv like before, is cosine, which means v will be the antiderivative of cosine, or v is simply sine. This is what we're looking for. We found our v. So in integration by parts, again, the integral of u dv is uv minus integral v du. This is what we're going to use, our IBP. So let's write this down. Sometimes, well, let's call this I again for now, right? We're going to call this whole integral to start with I. So I can say that that integral I will be my uv, which is e to the minus x sine x. uv minus integral of v, which is sine x. Now du is a negative e minus e to the x, or negative e raised to the negative x power dx, so that my I will be equal to e to the minus x sine x. This is now plus the integral of e to the minus x sine x dx. So again, notice that this is not I, but I'm going to have to use IBP again, integration by parts, where u here, again, I'll write it this way. U is e to the minus x, which will give you du being minus e to the minus x dx. And then you have your dv being sine x dx, which means my v is the antiderivative of sine. Or my v will become minus cosine. Let's double check. Derivative of cosine is minus sine, so yes, we're on the right track. Let's actually consider this. V u, oops, u in my du. All of this for IBP for this integral here. So let's write this down. That's e to the minus x sine x. So let's write it down on the next page. The integral of e to the minus x sine x dx will become, by IBP, e to the minus x, and there's a negative cosine. So it's negative e to the minus x cosine. Here's my uv. Minus the integral of v, which is minus cosine x. Now du is minus e to the minus x dx, minus e to the minus x dx. So this becomes negative e to the minus x cosine x. I got three minuses, or three negative signs. That makes this negative. E to the minus x cosine x dx. I have an odd number of negative signs here. Okay, this is -1, -1, -1 multiplied. Gives you that negative sign there. Okay. Well, I think we should notice that this is what we called I to begin with. That was our I, the original problem. So the original problem I equals, let's see, e to the minus x sine x minus e to the minus x cosine x. Minus again that I. Because I'm going back up here, in case you guys haven't noticed. This is what I is. So I found that integral. What I'm going to do now is add I to both sides, like before. And I get 2I will be e to the minus x sine x minus e to the minus x cosine x. And dividing both sides now by 2, I'll get I equal to, let's factor out that e to the minus x. Let's see what we get. 1/2 e to the minus x times sine x minus cosine x. Don't forget to add your constant. We are done. That's 7. Let's get another example, 8. Integral x minus 1 sine pi x dx. Well, we're back to that linear function here of x minus 1. We're going to let u be x minus 1, so my du equals dx. Remember, I could differentiate x minus 1. It reduces the power of the variable x. So it breaks down. Now my dv will be sine of pi x dx. Again, this is my dv. So v gives you sine pi x dx, or your v will be 1 over pi. Derivative of cosine is minus sine, so it's negative sine pi x. Let's think about that again. Derivative of cosine is minus sine, so the antiderivative of sine is minus cosine. Ooh, almost made another mistake. Okay. All right, here we go. This is my v, u, and du. So, IBP, the integral u dv is uv minus integral v du. What we end up with is the following: uv minus 1 over pi x minus 1 cosine pi x. This is uv minus the integral of, now v is negative 1 over pi cosine pi x, and du will be simply dx. So I get minus 1 over pi x minus 1 cosine pi x here, plus 1 over pi integral cosine pi x dx. I'm going to have to integrate cosine pi x dx. Now, we're right here. Obviously, it's going to be a nice t substitution again, right? T sub. Well, I mean, you could use u sub at this point because u's not available. U's available now. So, all right, we could use u sub. Where, of course, again, u is going to be pi x, and then du dx will be pi. In other words, by u substitution, this integral is 1 over pi. Now, the derivative of sine is cosine sine pi x by u sub. So altogether, our final answer will be here we go. Negative 1 over pi x minus 1 cosine pi x plus 1 over pi squared sine pi x plus RC. Hard to write down there. Looks like chicken scratch. Okay, let's kick this up. Number 9, I got x, tangent squared x, dx for u sub. This one is interesting because notice this. You might say, okay, I think it's a good idea. What we've been doing is we're letting u be x. And you say, okay, let's let u be, x. And then you get a nice du being dx. So that's going to be something very nice and workable for us, right? U is x and du is dx. But you say, okay, then my dv will be the rest. This will be my dv. And I have tangent squared x dx here, so that v will be the antiderivative of tangent squared x dx. Now, if you're thinking the following, that this is secant, the derivative of secant is not tangent squared. The derivative, ladies and gentlemen, of tangent is secant squared. So that implies that the antiderivative of secant squared, okay, will be tangent. Don't get this wrong. You have it backwards, and sometimes people do. They think you could integrate tangent squared and call it secant squared or secant, but you can't. We don't really know how to integrate tangent squared yet. It's coming, but we don't know the integral of tangent squared. So that means we're going to have to do something a little different here. So let's get rid of this. I'm going to keep the fact that this here is going to be used. Let me point this out to you. We're going to use this. Oops. We're going to use the integral of secant squared being tangent. Okay, so we're going to use this portion. I should say we're going to use this. How about if we try that then? Better. We're going to use this. But I'm also going to point out something interesting here. That I can replace my tangent squared with an identity. It's secant squared x minus 1. So replace tangent squared x with secant squared x minus 1. Now here's what you end up getting. Okay? This integral, x, now not times tangent squared, will be secant squared x minus 1 dx, which is the integral of x secant squared x minus x dx. So the difference of integrals, or I should say the integral of a difference, is difference of integrals. X secant squared x dx minus the integral of x dx. This is what we're saying here. On the right, I have the difference of two functions. I could simply integrate them separately. So if you notice the right-hand side over here, this integral is 1/2 x squared. That's easier to do. Now here's what I'm getting at. The second integral, we're going to have to use IBP, integration by parts. So by IBP, let's see what happens here. Again, we have something nice where u here is x. So we're going to let u be x, which gives us a du being dx again, just like above. And then notice now, I'm going to have a dv here. Well, my dv is secant squared x dx, which means v will be the antiderivative of secant squared x dx, which is tangent x. In other words, we are using the fact that I just talked about here. So let's put this together by IBP. So notice what we're doing. The integral of x, secant squared x, dx will be, now this is kind of, I'm going to transition a little bit. I kind of write it this way, uv minus integral v du. I kind of use this. You don't have to. It's integration by parts still. But it might make things a little bit faster, a little bit, easier, since I go back now and go, oh, okay, here's my u, here's my du, and of course, here's my v. So it's x tangent x. U times v is x tangent x. So this equals x tangent x minus the integral now of, well, what's v? The integral of tangent. What's my du? Du is dx. This is just the integral of x secant squared x. Now I have to integrate tangent, and if you guys remember, we did this actually. The integral of tangent, let's recall. We replaced tangent with sine over cosine, and then we use u sub. U sub, if you guys recall. U here will be cosine x, and so then du dx is the derivative of cosine, which is minus sine. Or you can say simply that dx would be du over minus sine x. So I'm going to replace this this dx with du over minus sine x. Let's see what we end up getting as an integral. The integral of tangent x dx will be the integral of sine, let's write it this way, the integral of sine over cosine times du over minus sine. Notice again what happens. Your signs will cancel. So you have this negative integral 1 over cosine x du. And don't forget now that this is negative 1 over u du minus natural log absolute value u plus your constant c. You could put your constant c, I guess. But remember that u is, let's see what u is. This is negative natural log absolute value of u plus rc. Let's go back here. U is cosine. So we replace this with cosine plus c. And this power out here, this negative 1, we write it this way, or at least I do. Just think of it this way. Negative 1 times the natural log absolute value of cosine plus c. Okay. I'm going to use my power rule for natural logs. And this becomes natural log absolute value of cosine, I should say, if you want to think of it, let's put this negative 1 plus c, which is now the reciprocal, 1 over absolute value of cosine, okay, which is where you get the natural log of the absolute value of secant, okay, all because of the power rule for natural logs. This negative 1 now becomes my negative 1 power here. And this is what we're going to use. It's the natural log of secant plus c. So let's highlight this integral here in, I don't know, green. It's part of our answer. Let's highlight all our answers in green. That was the integral of tangent, by the way. This here was part of integration by parts. That's our answer. And don't forget, originally, we had this 1/2 x squared. Everything in green is our answer. So let's write it down. How about if we put it right in the middle here? Let's erase this. Okay. We write the final answer. Let's put it in green. 1/2 x squared. That's the first part. And then, let's continue. X tangent x plus x tangent x. Oops. Okay. Finally, plus the natural log absolute value secant. Plus the natural log absolute value of secant x plus RC. And, there's some debate about whether I need the parentheses. If you notice, I'm struggling here with that parentheses around those trig functions. I do both. Depends on the situation. Anyway, let's just keep it simple. That's your final answer. And so now let's look at some more here that we can see. Some interesting questions. This will be number 10. So number 10 here. Let's look at this integral. 1 over, I should say, sorry. Well, let's try this one out here. The integral of inverse tangent 1 over x dx. Okay. Now, there's only one function again here. We did some examples in class where there's one function. If there's one function, I said try letting u be, that one function, because typically for IBP, integration by parts, we write it as a product of two functions. You have those two functions. Why one is u and the other is part of dv. There's only one function here. And so take a look. We're saying let this portion be u. Now what that means then is that dv, this is my dv now, will be dx. So that v will be the antiderivative of dx, or just simply x. Now we're going to have to find what du is here. So du dx will be, now this is inverse tangent. So the derivative of inverse tangent, and then it's going to be chain rule, is 1 over 1 plus 1 over x to the second power times, by chain rule, 1 over x. Okay? What happens now is that this is going to be negative 1 over x squared. We're going to have to do some algebra here. So this is going to be equal to 1 over, let's take a look here, 1 over 1 plus 1 over x squared. See if I can write it nice and elegantly. I'm not doing a good job here. Yeah, let's try it again. 1 over 1 plus 1 over x squared times negative 1 over x squared. Now, that negative sign, if you want, we could put it at the same level, or maybe we'll put it in the numerator here. See this? Now, the reason being, I'll say, okay, let's put in this numerator. So I can multiply the x squared on the bottom. We're multiplying fractions here. Let's multiply now our x squared here. See this x squared? Gets multiplied to everything here on the bottom. It's going to be distributed, by the way. So what you end up getting is going to be negative 1 over x squared plus 1 by the distributive property. And so that means du will be negative 1 x squared plus 1 dx. This is what we're looking for, right? Du is this whole thing. Well, let's put this together for IBP, integration by parts. We know that this is the integral of u dv, which is uv minus integral v du. So let's really focus on this, that my u is inverse tangent of 1 over x. So let's put this all together, and we got, and my v over here is x. So I'm going to multiply u and x. So that's going to be x inverse tangent 1 over x. X inverse tangent 1 over x by IBP. Now there's a minus the integral of v. Now v again is x. Okay. And I need du, and that's negative 1 here. X squared plus 1. And I think that's a dx here. So x inverse tangent of 1 over x plus the integral of x over x squared plus 1 dx. Notice what I have to integrate now is something I could do by u substitution. Okay? Where u is going to be x squared plus 1. So by u substitution, I get to integrate this particular integral. Okay, we're going to say u is x squared plus 1, which means du dx is 2x, or simply dx is du over 2x. This integral becomes x over x squared plus 1 times dx, which is du over 2x. Now, don't forget, x squared plus 1 is really, this is really u. So, let's put it as u. Notice the x's cancel, so this becomes 1/2 the integral of 1 over u du, which you know as the natural log absolute value of u plus your constant, 1/2 natural log absolute value of x squared plus 1 plus that constant, because of the fact that u is x squared. And that's what u is here. It's x squared plus 1, pardon me. I'm going to point out that x squared plus 1 is always positive, so you might see it as 1/2. Every time we get down here, my writing gets like chicken scratch. 1/2 natural log x squared plus 1 plus that c. That's the integral in red here. This is what we just determined right here. So altogether, final answer. This is x inverse tangent of 1 over x, okay, plus 1/2 natural log x squared plus 1 plus your c. Here's your answer. And let's take a look at some more. Let's do one more. I don't know what number this is up to. 10. We've got number 11 maybe now. Let's do 11. One more. Integral natural log x squared over x cubed dx. Now, we're going to let u be here. Remember, this is an IBP problem, so I'll let u be natural log x squared, which means du dx will be 2 natural log x, okay, times the derivative of natural log x by chain rule. This derivative is 1 over x. So I'll have 2 natural log x times 1 over x for du. So then we're going to multiply this by dx. So we get a du being 2 natural log x over x dx. That means dv has to be 1 over x cubed dx, which means v is going to be the antiderivative of 1 over x cubed dx. Let's be careful. V, antiderivative 1 over x cubed dx. Having a little trouble. V, antiderivative 1 over x cubed dx, which is the antiderivative of x to the minus third power dx, x to the minus 2 over negative 2. V will be negative 1 over 2x squared. Here's my V. Okay, let's take a look at what we're going to use. Here's my U. Yeah. Here's U. Yeah. Here's du. Doesn't matter. Integral u dv is uv minus integral v du. Okay. Ln x squared and a minus 2x squared. Okay. Ln x squared times a negative 1 over 2x squared. Let's double check. How about if we change some notation here? Let's simplify this. I'm going to say this is natural log squared x over 2x squared, and it's negative. Okay? Now, what do we have here? Minus the integral of v. Minus the integral where v will be minus 1 over 2x squared. And then we have du. Du is 2 ln x over x times 2 ln x over x. And then that's going to be a dx. Let's see if we can simplify this. This is natural log squared x over 2x squared plus 1/2 integral. Actually, if we look at this, our 2's cancel. So we'll have natural log x over x cubed dx. Let's take a look. Notice that the 2's cancel. 2, 2. And so this is what we end up with. So now I have an integral of natural log x over x cubed. Now let's see what happens. We're going to let u be here, natural log x. If that's the case, then we get du is 1 over x. Now let's see. So if u is natural log x, we have our dv here. dv will be 1 over x cubed dx, which means v will be the antiderivative of that 1 over x cubed dx, which gives us negative x to the minus 2, or and that's over, hold on, x to the minus 2 over minus 2, or negative 1 over 2x squared for my v. So IBP. And again, I usually like to write it as uv, I'll put it up here, uv minus integral v du. So if I know what my u and my v are, here's my u, and then over here's my v. That helps out tremendously. So I get natural log x, so that's going to be a minus 1 over 2x squared. Right, let's kind of be careful here when we get at the bottom. Minus 1 over 2x squared, natural log x. Okay, minus the integral of v, which is minus 1/2 x squared. And du here is times, oh, we forgot our du dx. This is dx. So that'll be times 1 over x dx. So I get minus 1 over 2x squared, natural log x, plus 1/2 over 1 over x to the third power dx. This is the integral I have to integrate. 1 over x cubed. The integral of 1 over x cubed dx from calculus 1 we know is the integral of x to the minus 3 dx, which is x to the minus 2 over minus 2 plus c, or negative 1 over 2x squared plus c. So there seems to be some integrals we're going to have to keep track of. And let's see. Let's keep it in green again. So here's one part of my answer. It's a multiple of 1/2. That's going to be a part of our answer. We have this portion. And then finally, let's keep track of that. That's minus, it looks like we have, where's our original? U ln x squared v, here it is, missed it. So let's put this all together. Start off with top. Minus ln squared x over 2x squared. And then we have minus ln x over 2x squared. Minus ln x over 2x squared. Okay, let's double check. Minus ln plus plus 1/2 times negative 1 over 2x squared. And yes, it's plus a c, and you're going to have that constant at the end. So this is negative ln squared x over 2x squared minus the natural log of x over 2x squared minus 1 over 4 x squared plus your c. And that one's done. Well, there we go.